Hi class, how are you today? That's so basic. The learning target for today is to be able to understand the basic terms of exponents and put monomials in factored form. The scale, for a 3, you can understand basic terms of exponents and put monomials in factored form. You're a 2 if you can understand basic terms of exponents or put monomials in factored form, one or the other. You're a 1 if you can understand some of the basic terms of exponents. And 0, you cannot understand some of the basic terms of exponents. Let's get started. So as the title of this video implies, let's start with the basics. The exponent tells the base to multiply itself that many times. So we have x to the m. So x is being raised to the m power. So x is being multiplied by itself m many times. And also, by the way, whenever you see x by itself with no exponent, what do we say the exponent is? 1. And that's the same thing for the coefficient and even the denominator of the fraction. See these dotted here? These are invisible ones. We say that if there's nothing there around the x, it's a 1. Nothing in front of the x, the coefficient's 1. X is not being raised to a power, the exponent is 1. X isn't being divided by anything, the denominator's 1. So, reminder, the number in front of the variable is called the coefficient. So, here we have 5y, so the number multiplying the variable, the number in front of the variable, is 5, so the coefficient is 5. Negative 1/2 x, the thing multiplying by x is negative 1/2. The coefficient is negative 1/2. Here, the coefficient is 0.7. 0.7w, what's multiplying by w? 0.7. But this one is negative m. So what's the coefficient? Well, what's in front of it is negative, but we can't say the coefficient is negative. It's got to be a number. So what do we say is in front of m when there's nothing there? Well, 1. But it's negative, so that means negative 1. So we have negative 1m, so the coefficient is negative 1. Now, what about if we have fractions? Well, what's in front of n here? Well, we have to include the entire fraction. We can rewrite this. N over 2 is the same as saying 1/2 times n. So in this case, the coefficient is 1/2. N over 3, 1/3 times n. So the coefficient is 1/3. N over 4, 1/4 times n. So the coefficient is 1/4. Now, how can we say these exponents? Well, we say a couple different things on a few of them. We have this first one is x squared, but it's also the same thing as saying x to the second power. The next one is x cubed, but it can also be x to the third power. But after that, we don't have very nice terms, so we have x to the fourth, x to the fifth, x to the sixth, so on. And so if it's x to the n, it would be x to the nth power. So if we don't know what it is, it's x to the nth, where n is some number. Now just a reminder, know the parts. The number in front is the coefficient, the variable is the letter, and the exponent, that's what the variable is being raised by. So the base, remember, the base is what's being raised to an exponent. So everything that's being raised to the exponent is the base, but you need to be careful because what's being raised is not always everything you see. It's everything that is next to the exponent. And that's it. So, got to be very careful. X to the m, well, the base is x. 3x to the m, well, the thing being raised to the m is just the x. Not the 3, just the x. 4x to the m, well, this time we're in parentheses. So it's the entire thing. It's the entire set of parentheses. Negative x to the m, well, again, only the x is being raised to the power. So only x is the base. But you've got negative x in parentheses to the m. It's the entire thing. So if you want multiple things to be raised to a power, you've got to put them in parentheses. Otherwise, it's just the thing touching the exponent. So again, we're looking at what the base is. It would be everything in parentheses. So here, it's the x. Here, it's xy. And in this next one, we kind of have two bases. We've got this full thing, all being raised to the third, but we also have this y being raised to the second power. So we have y is the base for y squared, and then the entire thing, xy squared, is the base for xy squared all cubed. So in this one, we have two bases. All right, now let's look at factors for a little bit. And so we have a composite number and a prime number, which I'll get into in a moment, the difference between the two. But let's look at the factors. So what are the factors of 12? Well, the easiest way to find out those is what two numbers will multiply to give you 12? Well, we have 1 times 12. We also have 2 times 6 and 3 times 4. So we have 6 different factors. 1, 2, 3, 4, 6, and 12. What about 7? Well, we have 1 times 7, and then that's it. So that's the difference between composite and prime numbers. Prime numbers are always 1 and itself, and composite numbers are much more than that, more than just 1 in itself. So prime numbers, we've got 2, 3, 5, 7, 11, 13, 17, going on forever. There are infinitely many prime numbers. But the special thing about them is they only have two different factors, 1 and itself. So 2 has the factors 1 and 2, 3, 1 and 3, 5, 1 and 5, 17, 1 and 17. So prime numbers only have two factors. And there's no nice pattern to find prime numbers either. It's just what can they be divided by? If they can be divided by anything except 1 in itself, then it's not a prime number. Otherwise, it's a prime number. Composite numbers. So these are non-primes. These have 3 or more different factors. So you've got 4 has 1 and 4, but also 2. 6 has 1 and 6, but also 2 and 3. 8 has 1 and 8, but also 2 and 4. 12 has 1 and 12, but also 2 and 6, but also 3 and 4, and so on. Perfect square numbers. These are numbers that give us, well, perfect squares. You can make squares out of them. 1 squared, well, if you have 1 square, it makes a square. 2 squared, you've got 2 times 2 gives you 4. So this is where area comes in. 3 squared, 3 times 3 gives you 9. So any that make a perfect squared is a number squared. These are known as perfect squares. So I have a list of the first 10, but just like primes and composites, they are infinitely big. There are infinitely many perfect squares. It's any number and then squared. All right, now let's talk about factored form. Taking exponents and putting them in factored form. So the exponential form, which we've been dealing with, is you take a base and you raise it to an exponent. Factored form is taking the base and multiplying it by itself as many times as the exponent tells you to. So factored form for negative 3 to the fourth would be negative 3 times negative 3 times negative 3 times negative 3. So negative 3 4 times. And the customary notation, or the answer, well, negative 3 times negative 3 is positive 9. And the other side, the other two, are also positive 9. So 9 times 9 is 81. Now this next one, we have in the factored form 2 times 2 times 2. So for the exponential form, we know that this has a base of 2. It's the base that's being multiplied multiple times. In this case, it's being multiplied 3 times. So it's 2 to the third. And so customary notation, 2 times 2 is 4, times 2 is 8. And now last one, we have customary notation, which is 100. And we know that to be 10 times 10, which in exponential form, we have the base is 10 and it's being multiplied twice. So 10 squared. All right, now let's put a few more of these in factored form. We've got 3 squared. Well, the base is 3 and it's being multiplied twice. So 3 times 3. You can put it in parentheses, or you can just write out the multiplication. Next one. What's the base here? Know the base. So the base is x. That's the base. So that means the 4 is just by itself. The 4 just stays there. It's not being raised to the third power. It's just a 4. Then x is being raised to the third power. So we multiply by x 3 times. And that's that in factored form. Next one. Negative 5 squared. Again, know the base. The 5 is the base, not the negative. So we have negative and then 5 squared, so 5 times 5. And then the last one, this time the entire thing is being raised to the third power. So we have 4x times 4x times 4x. Because 4x is being raised to the third power, so we have 4x 3 times. So again, the big difference between negative 3 squared and negative 3 squared. Say it with an awkward pause. We've got negative 3 squared and negative 3 squared. Sometimes I also like to say if multiple things are being squared or raised to a power, I'll say negative 3 all squared. That way you know everything I just said is all being squared. And the factored form, remember, we've got this one is negative 3 times negative 3, because all of it's being squared, but the other one is negative 3 times 3, because the negative's in front, and then we've got 3 times 3. All right, and one thing to remember when you're dealing with powers, if you have an odd number of the exponent, the answer is going to be negative. If your exponent is even, your answer is going to be positive. So one more thing to remember, if you're raising a negative number, again, all the negative number, know the base, to an odd number, then it's always going to be negative. And if you raise a negative number to an even power, it's always going to be positive. So it doesn't matter what those numbers are, as long as your exponent is even, then it's always going to be a positive. If your exponent is odd, it's always going to be a negative. But that's only when you raise a negative number to an exponent. All right, and then quick review. Remember, if you've got x to the m, you've got the base being raised to the exponent. We've got prime numbers that only have two factors. Composite numbers have 3 or more different factors. Difference between -3 squared and -3 squared. Know the base. Coefficient's the number in front. Variable is what's being raised. And the exponent is what's doing the raising. If you've got negative n all raised to an odd power, the answer is going to be negative. If you've got negative n all raised to an even power, the answer is going to be positive. And remember, if it's just x, you've got 1 for a coefficient, 1 for an exponent, 1 for a denominator. And any number squared will give you a perfect square number. All right, now time for the sponge. So 6 problems that I misnumbered, sorry. But identify the base of each expression for the first 3. So what is the base? Tell me what the base is. And for the last 3, change each expression into factored form. All right, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Attempt the sponge activity. Take a picture of everything. Submit it all to Google Classroom. And have a good night.